And welcome, folks, and thank you very much for joining us again at America's Feature Series, Space Talks with Z. I'm Z. Welcome again, and how are you? We want to thank our sponsors for making this possible. It can't happen without them. The Zoom, uh, digital media, etc. All those resources are thanks to their generous support. Today we have joining us from Washington, D.C., Robert Feirerbach, a space industry professional. Robert was trained originally as a computer scientist at the University of Utah, and then, like me, he went to Thunderbird and got a master's in management. We don't just do MBAs at Thunderbird. We teach more than that. And his path has been very interesting. Um, like so many technical people who go into management, there are perspectives that he has that are unique and insightful. And so, welcome, Robert. Thank you so much for joining us today, sir.
My pleasure, Z.
Robert, before we go too much farther and get into some of the meat of this discussion, I'd love for you to share with us your path to the space economy.
Well, it's an interesting one, Z, because I didn't see myself as a space person whatsoever as a kid. In fact, I was kind of a musician more than anything else. Played all kinds of instruments and rock bands and things like that. Uh, and plus, I had really terrible eyesight, so I couldn't see much, and I couldn't see even the stars in the sky until I was a low teens teenager, and I discovered I needed glasses. So it wasn't something I had envisioned, but I loved the stars. Once I got glasses, I realized, oh my gosh, look at those things I never saw for years. They're actually really beautiful in the sky. So my attention to telescopes and stars and things like that was always there. But the way I got into the business was interesting because I was graduating with my MBA, and I was ready to go join General Motors because I'm a closet mechanic among other things. So I love cars.
Very
I
cool.
love working on engines, and I was going to work in Ann Arbor, Michigan. But this guy calls me in, and at that time, I couldn't really look companies up. We couldn't look them up anywhere. We didn't have internet, right? I'm aging myself, I know a little bit, but and anyway, so this company called Ecosphere International comes in, and they're going to interview for some jobs, and I didn't know if they were selling trees or building trees or planting trees or what, something with ecology. I figured I didn't know anything about them, but I walked into the meeting, and it turned out it was the predecessor to EchoStar or Dish Network here in the United
Wow.
States. And these guys, Steve Shaver, who was also Thunderbird, former Thunderbird, and the founder of the company, Charlie Ergen, who's also Thunderbird, had only been hiring out of Thunderbird for international, recruits. So I found out during the meeting what the company did. We just clicked with the guy that was talking to me. He was fluent in Spanish, and he was an American, but he was fluent in Spanish. So we started talking in Spanish. And then next day he sends me a ticket to go to Denver, see the headquarters of EchoStar. I did my round of meetings there, and a week later I was in the Netherlands at their very first international office. And at that time, the industry was going from those very, very large satellite dishes you see still in the farmland here in the United
Right,
States. They're
right.
abandoned, the black ones and big ones there. That was satellite back then, right? But Europe was going to launch these high power satellites that would allow you to see things with a pizza sized dish. And they were the first ones. So Charlie Ergen said, I need a team of people that speak multiple languages, that have technical backgrounds. I need to stick them in the Netherlands because the Netherlands has good logistics. We'll go to Rotterdam, and then we'll see what we can do. Let's see if we can, sell satellite equipment, because he was already selling stuff in the United States. So I was one of them. And then I became the sales manager for the group for 11 MBAs that were there about a year and a half later. And the rest is history. I've been in the satellite industry and the space industry ever since. So that was the way, unbeknownst to me, that I kind of got sucked into the space industry, and I never left it. It's just a wonderful, wonderful path for me and a wonderful career. And I learn something every single month or every single year. And it's a passion to me now, Z.
Spectacular. So you're shanghaied onto a rocket, uh,
Yep.
straight to orbit. So that's really interesting because it segues to one of the things I think you're uniquely positioned to help us understand. as a group of people interested in space economics, is that initially defense and telecommunications, and somewhat communications for defense dominated, the space economy, and things like companies like Dish were at the forefront of commercial uses of space. Um, Now we are seeing that transition dramatically. Can you help us understand the different layers of space and perhaps the different opportunities that are real, not cutting through a little bit through a lot of the hype that's out there right now?
I guess you have to differentiate between sort of the government defense side and the commercial side, right? In my belief, the true moment when the commercial business really started in a big way in space was the advent of these high power satellites in Europe. They did it before we did it here in the United States. That changed the game in terms of numbers and reach. A number of people using this kind of technology. As I said before, these guys, you had about 3 million people in the United States back then using these big satellite dishes in the backyards, and that's all they could see CNN and a few other things back then, right?
Right, right.
But you had to go chase signals, a couple channels here, a couple channels over there, and your antenna had to move. It was motorized, right? When these small pizza-sized dishes came in, and all of a sudden you can direct your satellite antenna to one position and get 16 channels in one position, that was groundbreaking. And the numbers changed. What happened there was that from those 3 million people that were watching it in the United States that had their satellite antennas, all of a sudden you went to a marketplace where just Germany was consuming 70,000 systems per month in terms of 70,000 per month back then. And it was just a crazy number. I mean, those numbers were never seen ever in the satellite industry, right? So that's when I think you came from sort of a government kind of thing, and then maybe a corporate networks that communicated and fed video signals to head ends, and the head ends then through cable distributed them to households and so forth. That's when it really translated to getting antennas in people's homes in a big way. And that's where obviously Charlie Ergen got the idea later on when he said, the market's crazy in Europe. I need to do this in the United States. So that's where he created Dish. And he came over to the States and applied for his licenses for frequencies. And then he was one of the 4 operators back then doing that. So, yeah, I mean, that's when I think, in my view, the industry really changed. And it became very consumer focused in terms of numbers and reach and in terms of the general population. Other than that, a lot of things happened after that, and another many multiple ways for two-way broadband access. Went from analog to digital, and digital back to two-way, and having internet services as well. But that's really I think was the inflection point back then.
And so since then, you've worked for a lot of amazing companies. Some that are kind of perhaps people know better would be Hughes and SpaceX. How do you feel your experience was different with SpaceX and the opportunities that it has presented to the world, frankly, or really what the modern space race at some level that it spurred has provided to the world compared to where the world was when you were working for Charlie and Steve and kind of conquering these markets, delivering data via satellite?
Well, the entry into my return, I guess, to the United States after being, about 18 years in Europe,
right,
was one that allowed me to work with Hughes and H&S. Those guys are very good at what they do. The market terminals across the world, and I was the head of international for them. So the big difference here is that in order to launch those big satellites that we had been launching until then, these are bus-sized satellites, right?
Right.
And each one of those satellites weighs 6,000 tons, or 6 tons, I should say.
Right.
So they're big birds, and these big birds needed to be lofted with big rockets, right? So the big rockets were the Russians, the Europeans, and to some extent a few of the Americans as well, from ULA. But really, really, the market was cornered pretty much by the Europeans and the Russians back then. So I get headhunted by SpaceX. I joined SpaceX, and I remember multiple meetings where we were sitting over in Europe, speaking to counterparts in Europe that were in the launch business. And they kind of laughed at us and said, "Oh, you guys are cowboys. You're never going to do this stuff. You never." We talked about reusability because, you know, Elon has a very, very forward-looking vision of what he wants to do. And even back then, when he was designing the rockets, he was designing the extra propulsion capability and the extra space around
It was
around a rocket
already they
to
were
be able to
making
land
it.
them.
Wow.
Yes,
Even though they didn't
that's
tell
how.
anybody. They didn't tell
That's
anybody that.
that's right. But Elon thinks that way. He thinks very far in the future. So we would, you know, do our pitch to try to get some launch contracts and say, yeah, we'll do reusability one day and we'll bring rockets back after they've flown and so forth. They laughed at us and said, you guys are a bunch of cowboys, American cowboys. This will never happen, right? So I think what's really changed there is that there's a true belief that reusability, and I guess it's a proof now too, that reusability does lower the cost of access to space. It does allow you to use a model where, like a business jet or a big, you know, commercial jet, you don't use it once and
Right.
land from
Right.
Tokyo to
It's not
Beijing.
expendable when you
It's
ship
not expendable,
something.
right? Exactly. You use it
This is
over
shipping
and
now. It's
over
no
and over again.
longer launch in the way we think about it. Now it's shipping something to orbit. And
You
you
got
expect
it.
the vehicle to come back.
Become a bus that is reusable,
Right,
right?
right.
So that's the true end goal of the whole thing. And by doing that, of course, you're lowering dramatically the cost to access, and cost of access translates into cost of your program and ROI on your system, on your satellite system.
Right.
So one thing that's happening now, which is very exciting, is that because of these technologies being available and because of miniaturization, and, you know, putting iPhone type of electronics in your satellites, there's a huge economy in the low Earth orbit side, the LEO as we call it side, that is thriving today. There are a couple hundred manufacturers of LEO satellites and components around the world. There are about 100 companies trying to design small launch systems for these small satellites, and they're trying to in a way continue to lower the cost of access to space. And so you have smaller form factor equipment. It doesn't need to last 15 years anymore because you launch it into LEO, you'll bring it back in, you'll keep launching new generations. So the idea of launching small constellations of 50 to thousands of satellites together and letting them fly around certain orbits very, very low to the Earth, not only gives you a better visibility of the Earth if you're doing Earth observation kind of systems, you know, for imagery, but it also gives you a better latency in terms of access of that signal. You don't have to travel all the way up to the geo orbit. So when you do a double hop to geo orbit, you're looking at about a half a second to 700 milliseconds, you know, 0.7 of a second of latency. And that doesn't, I mean, it's great that you have it there, obviously, but that doesn't give you the same experience as if when you're in LEO and in the low Earth orbit. And so these new satellites now are being built to be expendable, to last 3 to 5 years max. And you launch many, many of them in formation. And with a formation flight, that allows you to have the same kind of capability and connectivity for internet and for whole bunch of other very cool analytical services as well, that has changed the game. And so these launch vehicles, reusable launch vehicles, are able to loft 50 or 40 or as it was last month, 145 of them.
Right.
Launch, right?
It's remarkable.
It's changed the game. The game has totally changed, and it's the most exciting time right now for me in my close to 30 years in the industry to be in this industry, because the space economy is just booming right now. There's a lot of big investments being made, and you heard of a few the last 2 weeks, 3 weeks of some of the SPACs that are happening in space.
Right.
It's crazy. A lot of money going into space right now because it's actually really exciting, and there are very, very cool services coming out of it as well.
Now, you mentioned surveillance and communications. What this renaissance is providing is a level of data about the Earth that we've never had before. And how do you, as being in sales, right? The core of a business at some level, sales and innovation are the two things that generate
Absolutely.
revenue, right? I think there was just, that's Deming, right? The old phrase, everything else is a cost center. Um,
That's right.
so, so from the sales perspective, how do you see, and is there a feedback loop between the modernization of artificial intelligence and the capabilities there, driving a hunger for data, which drives more AI capability? It's kind of a feedback loop. And is space part of that now?
Well, it is in many, many ways in terms of the sheer volume of data that we're downloading now from multiple operators on the optical side that need to be transferred in or transformed into a service, right? You know, uh, 10, 15 years ago, there were imagery satellites producing a whole bunch of pictures, but basically you had to manually go through them and look at change detection between one pass and the next pass and the next pass in the same part of the Earth and see if anything changed, right? Well, now you have, a few thousands, and soon you will have tens of thousands of satellites producing the same amount of data. There's no way you can do that manually, right? So
Right.
AI is a big part of it. Change detection is being done by machines, so that when you see a vehicle that wasn't there the first pass, 90 minutes later,
Hmm.
there's one there. There's something automatically happening, and there's an interpretation of that data, right? So those kind of services are really, really multiplying. We're looking at companies, for example, that are putting just small sensors that can detect little radio signals from the Earth and create services with that. For example, ships that are traveling around the oceans. Piracy is a big problem on Earth today, and a lot of ships just go dark, and you don't know where they are,
Right.
and
They
then
turn
they
off
kind
their
of go
transponder and then they
turn off
pop up wherever
transponders.
they turn it back on.
Exactly. So with imagery to begin with, and then when you disappear, you do radars, small radar sensors on the satellites. You continue to track that same vehicle, and then now you have a tracklet that's been formed, and you know where it's continuing to go. That creates a service as well, and that's being offered as a service to these operators, for example, and then they know exactly where this vehicle has disappeared and where it continued to go because they're tracking them. So things like that are just very, 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 very fascinating. I mean,
Right.
look at, for example, our good old GPS, right? It's been
Right.
around for a long time, and we have the utility of it is
It's changed
uncontested.
so
I mean,
much. It,
absolutely for us
it's a
here on Earth, right?
utility. I mean, basically, right? We take it for granted, but it
Yeah,
it really is
it's
a remarkable thing.
remarkable the kind of things that are happening, right? But so another company decided, all right, well, there's GPS in space, so what if I put a few satellites in space, and I want to be able to create some weather uh, graphs that look through the clouds by accepting that ping of that GPS signal as the satellite's coming above the horizon. I look at the ping of that signal, and as it's coming, there's a bending of that light
Hmm.
of that ping as it goes through the clouds because it's going through different layers of atmosphere, right? As it's coming up or as it's
Right. Right.
going
Right.
down. And if you detect that properly, you would not believe the amazing 3D graphs of clouds that produces just by looking at pings of GPS signals by satellites up there that are detecting these, and they're detecting them from all directions, right? Rising and
It's basically like a
going
type
down.
of tomography they're doing.
Yes, yes. And that's being offered as a service now
How
as well.
spectacular. So you've
Crazy
mentioned the
things.
word service multiple times. And in the past, people have thought about putting up a surveillance satellite, putting up a communication satellite, and sometimes we think about things very far out, like going and getting resources from an asteroid,
Hmm.
building a base on the moon or Mars. We need to think perhaps more about what we would do there to generate value besides science. Not that I'm a scientist by training. The science has immense value, but at some level, if we're going to colonize, there is going to need to be a commerce perspective there, and people will need to have a reason to be there. Um, what about space as a service, right? You think of logistics on Earth, right? Suborbital logistics, right? They're all fundamentally as a service, right? DHL, FedEx, UPS. That's logistics as a service, right? Because you're buying somebody who's going to take your package and make sure it gets somewhere else, and they're doing all this stuff for you. They're serving that, right? what do you see space becoming an arena where there's many things offered as a service, or do you also see it as an arena that is going to be a destination, and perhaps on what timelines?
Well, I think probably both to answer your question to begin with, right? I mean, destination, certainly. It's happening today. There are private citizens hitching rides and paying for rides, future rides in the next 2, 3, 4 years. Axiom is one of those companies that they announced a few days ago. They did a funding round and so forth. So the space tourism part or the visiting part, visiting habitats out there will always be an interesting market. But the real big market, the real monster market is not that. The monster market is a way to create infrastructure and build it in space. And so there are a
Mm,
few companies that are concentrating on exactly that. You can't bring all your raw materials from Earth to build it in space. If you
right.
do that, it's very expensive. Look at the ISS. It's been an incredible marvel and it's still up there and it's still being operated, but it's cost hundreds of billions of dollars because you bring everything up on rockets with you.
Right. The launch
So
cost is simply prohibitive.
well, yeah, the launch cost and of course the volumes, you can't carry that much volume either for
Right.
big
Right.
habitats,
Right.
right?
It's not. Yeah.
So,
That's right.
so you have to, when you think about inhabiting other rocks like the moon or Mars or anywhere else, you have to think of a way that that you can use raw materials there to build to build your own habitats and your own infrastructure there. Look at a company that raised 500 million bucks about a month or two ago. Relativity.
Yes.
Relativity is a
Yes.
rocket
I
company,
interviewed Tim Ellis actually.
right? Yeah.
Yep.
Oh, that's there you go. And as you know, Tim built his company to basically 3D printers to build rockets, right? Well, that's great. Building rockets at a reasonable price is great, and we see a few others doing the same thing. But that's not the finality. The finality, what they're doing, is to be able to allow you to 3D print objects with raw materials you'll find anywhere on any rock
Right,
out
right.
there in
And Tim
space,
mentioned that. Right, he wants to see
right?
a 3D printer or a relativity factory on the moon or on Mars building stuff for the
Absolutely.
habitats or building the habitats themselves.
And that is, in my opinion, as an industry guy, that's the reason why the valuation of relativity is so high. They still haven't launched anything to space. Nothing. Nothing yet. Machines are great and the factories are great, but it's this idea of being able to have a mechanism, a way to be able to transport something and build things locally when you're
Mm.
there.
I mean,
That's the future stuff.
even the concept of figuring out how to use lunar regolith to make lunar concrete could be
Correct.
critical, right?
Absolutely.
There are systems that can enable you to 3D print concrete, so you can make large, gross size structures, right?
Correct. You have to take a few polymers with you to be able to bind these materials, but if the material you need to take up there is 5 to 10% of the total, then you're doing pretty well. So
Right,
the
right.
other ninety
But we
percent
don't
is
want to be
locally
launching
sourced.
quick. I know how heavy those bags are. I've done a patio.
Yeah, yeah,
Not a good idea. So,
correct, correct.
that's thank you for that. That's really critical. Is thinking about how we build there and how we use materials there locally. You said something to me that was similar actually before we started recording. You said that here everything, all business is local now, and you've gone from kind of from America to Europe, being quadrilingual, and being a Thunderbird, which means you're able to kind of work all over the world, uh, you know, and it seems like space was born global. Space didn't become global; it was born global. So, I'd love your perspective on that, and your perspective on how that makes sense with the statement that all business is now local as well.
Yeah, I mean, obviously, the fact that the space industry, and space connectivity via satellites is by default something that is from point A to point B somewhere on Earth, right? You're not using terrestrial infrastructure. You're going to space for a reason, and that's because you're trying to go to places that are not well covered or places that don't have infrastructure on Earth to transfer signals. So that's always been the sort of the default case for space, for space connectivity, or be that internet or
Coverage.
be that coverage outside of your local populated areas, outside of large towns and big cities, right? So by default, space has always been global, right? No doubt about that. And I think EchoStar back in the day when they were thinking about that, they realized that too, as global people themselves, as former Thunderbirdites. They realized that they need to hire people that were absolutely easy to adaptable to begin with, but also people that could pivot very quickly to understand what's going on in country A, country B, country C. So I was made in charge of Austria and Switzerland and France at the time, because I spoke the languages. So, but all of us sort of pivoted and figure out, oh, this is the big opportunity country. This one's maybe not so much anymore, and so forth. But space by default, space is always space connectivity or space comms have always been sort of a global thing. I think they're changing a little bit now because there are other services, and you see these that from your GPS on your phone, they're very personal, very, very, very much in your house and in your home today. But at the core, space has always been global. Absolutely. See?
And so how does it become local then? Going back to the other statement about all business is local, because it sounds like there's a segue there, right? Space is in the palm of our hands now, right? I mean, all that data is coming, bouncing off 5 satellites, over to us when I'm talking to my cousin in India on WhatsApp or what have you.
Right. Well, technology is developing and it's advancing, right? So if you want to communicate, for example, to this little guy here, this cell phone from space, very difficult unless you have an antenna, a satellite antenna to receive the signal, to concentrate that signal a little bit, point at a certain place. Even with the LEO satellites, you need to follow the signal. So they have to be electrically steerable or mechanically steerable to follow the signal. But you still have to concentrate that signal because it's very weak. It's coming down. If it were too strong, you'd be, everybody would be cooking
killing
down,
birds.
right? Yeah, killing birds and stuff. So you can't do that. So because you have to do that, there are companies saying, all right, the real big market, the trillion-dollar markets, are not going through a regular satellite antenna, and from the satellite antenna going down to homes or whatnot, to modems, for example. The real big markets are going straight to a regular consumer phone. But this little guy here transmits 2 watts, right, of power, not more than that. So the connectivity is limited to your cell phone towers, and you know that as you get far away, you get 1 bar and 2 bars or whatnot. So one of the things that a couple companies now have successfully been able to test is to put in a satellite up in space that is flying in low Earth orbit, but you'll put on a football size antenna on it, and that football size antenna will actually use the frequencies you're currently using on your cell phone to establish a link with it. And when you do that, you're talking about a different scale. You're not talking about hundreds of thousands of terminals per month being sold. You're talking millions and millions of terminals, right?
Yeah.
Or millions and millions of subscribers.
Right. I mean, a billion within a couple of years, certainly. Right. You just take the populations of Europe, America, and the affluent areas, parts of Asia, and boom, you're at 1 billion people within 24 months. Now that's remarkable because I've used a sat phone on Sophia. We carry one for emergencies.
Right.
Of course, but that's that kind of old style sat phone that looks like those cell phones from the 80s, that were gigantic, the bricks, the bricks, I'm not talking, the real bricks, right? So it's just remarkable to think of that opportunity and what that would mean for communications and what it could open up for business.
Yeah, I mean the innovation is happening, and the solutions are being tested and being refined, and those will be available in the next few years because we are all engineers at some level in terms of iterating and improving things that we're doing, and that iteration takes place so quickly today, which is incredibly fun for people like you and I, obviously. Right?
It's spectacular. Now, I also wanted to ask you about your company. You are president and founder of Clarkebelt Space, And could you tell us more about Clarkebelt and what services you offer through that?
Yeah, a few years ago, I mean, I had this company now since I think 2004 or so. I've had a few engagements with particular types of customers that needed some solutions. I worked, for example, very closely with one of the accounts was OneWeb, one of the constellation players
Oh
today,
yes, yes.
on behalf of MDA in Canada. So I've always kind of connected sort of I wouldn't say a foreign, but maybe an ex-US entity with some things that are happening in the United States. So I found a really good place to be able to provide expertise from the space industry to companies that are either wanting to use US technology and bring and use it and integrate it and do something with it and overseas, or the other way around, companies trying to do something in the United States. So I've been continuing to do that. I've been working with everything from space debris analytics to lasers to manufacturing of components and sensors for different kinds of small form factor satellites. Now, for me, it's an activity that really keeps me up to date. And I really enjoy because every time a new project is something that forces me to learn a little bit extra about a
Very,
particular area that
very
maybe I
cool.
didn't know about, and then just dive in. And so I've been used very often to do the deep dives for companies, and then establish their business plans and their maybe the strategy there. So that's what I've been doing for quite a while now, and I'm very busy most of the time too with multiple customers. But I'm also the founder of an aerospace startup company that will be in space support services area. And that's providing different kinds of services for companies that need to develop technologies for access to space, develop technologies for equipment and for services in space. It's in stealth mode today, but Zero G Launch is a company that I formed about a year ago with a partner. And we're currently in the fundraising mode to get it going, but it's going to be very laser focused on a segment of the industry that is not very well served yet today, to be able to develop technologies quicker for access to space.
Sounds exciting. I think when you come out of stealth mode, we're going to have you back to chat about that.
You bet, you
It
betcha.
sounds intriguing. Um, Now, what's another area that I would like to ask you about is how you think uh, different the economy is going to move forward. So let's look forward a little bit now, and think about, there's been a lot of hype right now from satellites and data. What do you think is next? Is it tourism? Is it manufacturing? As somebody who knows a tiny bit about crystallography, for example, and growing crystals, I'm actually interested to see what whether, and go back to some old textbooks to see if there's some interesting things we can do in zero G or near zero G, because gravity is influential in so many chemical reactions and crystal formations and such. Where do you think that next wave will come from? Because right now it seems to be about comms, and this is comms to serve the commercial market and retail market, and different types of data resulting in space as a service in different ways, whether it's weather data, whether it's ecological data, or monitoring fisheries, as you mentioned. What do you see as the next big wave?
Well, I have to say that, I mean, it's a complex one, but I really believe, and as a space professional, I really believe that the next big wave will be the real commercialization of infrastructure in space and working in space and and inhabiting space on a commercial basis. Now, you have to make it. You have to have some sort of an ROI when you do that, right?
Right.
I mean, you don't just take things and have very expensive experiments and use $100 million rocket to bring them up there. But I think in the next 20 to 30 years, we will start seeing multiple habitats, multiple activities happening there. I remember 15 years ago or so when I heard about space mining, I thought, Come on, that's crazy. You're not going to go get an asteroid and then pay $100 million or $200 million to reach it with a special spacecraft, and then somehow bring that back to Earth. That doesn't make any sense, right? Well, it doesn't make a lot of sense when you bring it back to Earth, but it makes a lot of sense if you keep it there and you do something else with it, right? So
Right.
that's what I think the true activity will start, and we're talking probably 20 to 30 to 40 years from now when that'll be a big activity, but it'll be one where many people participate and many people are having activities that are building big structures in space. And again, listening to Elon Musk and to Jeff Bezos, they really in their hearts believe that humanity has to exit this rock here just in case one of those civilization ending events happens with a big asteroid coming in, because it will happen. It happened 3 4 times that we know of, that we can estimate in the
Yep.
past. It will happen. It's not maybe tomorrow or the next maybe the next 100 million or next billion years, but it will happen, and humanity will disappear. So they truly in their hearts believe that it's a prerogative of humankind to go and start being self-standing in other areas around the earth or outside of the earth and other rocks, because at some point something will happen, right? And I believe that too. I
It's
would be the first.
statistical. It's
Yeah,
just
it's just
statistical.
exactly.
And even more in the more short term, a lot of the technologies, we had Miranda Satterthwaite of the Antarctic Center from New Zealand,
Mhm.
and she's done a lot of work in using Antarctica and New Zealand as an analog for space for human exploration. And one of the things that she'll talk about a lot is that there is a huge opportunity to learn how to be better on Earth thanks to space technology. Not just to have cell phones and emojis and cool chat, but to find out how to be better farmers and to use power better. What I was also interested in is that, that you might have a perspective on is from the infrastructure perspective. Could we see manufacturing move off world? Things that are possibly um, uh, things that are possibly polluting or otherwise. Why not do that? Could we see that move off world to orbit or off world to the moon or Mars rather than going into rivers on Earth?
Well, I mean, obviously, depending on the volumes you're talking about, some things could be feasible. You could bring, you can repatriate certain objects and things back, and then use them when they come back to Earth, they land. But it's still a very by and large a very expensive thing to do. So one area where I think, and you mentioned it earlier, also Z, an area that has a lot of promise because the size of the objects or the size of the matter you need to bring back is small, is the pharma industry. And in the pharma industry, when you're in microgravity environments, you can produce certain crystals and certain microcomponents that maybe not that voluminous, but are very key for certain types of developments in pharmaceuticals and in drugs and so forth. So I think that's an area that has I think quite a bit of promise out there. I'm not a big expert on pharma, but I know a few companies that are involved in this, and one of them is also just launched a satellite 3 4 months ago that had a whole bunch of micro experiments that
Interesting, wonderful.
self-standing, space pharma based in Israel and Switzerland and Palo Alto. So this company, space pharma is very cutting edge, and they're a big believer, obviously, that there's immense benefits from creating certain kind of compounds and certain kind of crystals in space that we can benefit from here back on Earth. But I think from my perspective is it's a question of volumes. If you need to bring, large volumes of things back to Earth, it's pretty hard and pretty expensive, right?
Very interesting. So, I mean, there will be parameters that govern that, and I guess define the ROI.
Yeah.
Always comes back to the ROI. We're coming into the last 5 or so minutes here. So I want to ask you also, here at the America's Future Series, one of the things we're very concerned about is maintaining kind of the edge that America and its allies have. We have a lot of near peers now around the world. Chang E5, for example, was a remarkable display of capability by China.
Mhm.
to send something robotic, artificial intelligence. I mean, it's just a beautiful integration of so many different types of technology and return a sample successfully. That is so non-trivial. I don't know
Oh,
that most people really
that's an
understand.
understatement. Yeah.
It's immensely complex and risky and challenging. What so if there are peers around the world, what can we do in America, both in government, in business, in education, to maintain our edge, to be the best that we can be, and ideally the best in the world. And please be prescriptive. That's one thing we love, with America's Future Series, is for you to say what you really think needs to be done.
Well, I fully agree with you to begin with. You look at China, you look at India, for example, they've been tremendously successful with their space programs, and they're continuing to innovate. They're pouring quite a bit of government money to those programs, so they're attracting a lot of people, a lot of smart people to those programs. In our case, in the United States, our budgets are getting smaller for space, at least from the government point of view, right? From the commercial side, they're as large as they've ever been. So there is that innovation that's happening here because venture capitalists and angel funding is very, very much alive in the United States, right? So one of the things that I think is very much of a danger for us in the United States is the issue of not emphasizing and not being able to make attractive enough STEM education on not only at a high school level, but even later on. I think there's a belief now that well, I can make $1 billion very quickly by becoming a CEO of a startup, right? Kind of thing, and it's not reinforcing the fact that there is a certain amount of knowledge you need to get on a technical side to be able to do these complex things that you need to do. Now, of course, you can code and you can do a few other things like that too, but there's a lot of complexity in building structures and doing things, and then being able to access, platforms and build platforms that allow you to do these incredible things for space. And that takes, quite a bit of
Takes the
engineering. And I think,
technical talent.
yeah, it does. No matter what it does, right? So I think we're kind of we're kind of letting go a little bit of that, and I think it's a pity because that's really really a strong requirement. I think to continue to stay on the forefront of technology as a country, right? I mean, another area that I think is in parallel there is hypersonics. That's more of a DoD focused area, but hypersonics is an area that allows you to take something very quickly from point A to point B at Mach 8, Mach 9, or Mach 12 even through the atmosphere, right? Very, very complex. Well, the governments of China and Russia are putting a lot of money into that today. They're starting to show some hardware that they claim to be able to do certain things, to have certain capabilities, and that's a big danger for our country as well. So the DoD now in the US is pouring quite a bit of money, luckily, to be able to motivate and incentivize private companies to cooperate with the DoD through some agreements there. And I think that is a good thing that is happening because it's going to keep us on our toes and allow us to continue to develop things by helping the DoD through commercial companies and private companies, rather than having the government do it all at the government rates and government prices, right? So some good things, some bad things, but I think at the core of all that, I think it's very important. The education part is probably very, very key, at least for our young kids, the young population today.
Well, thank you for that, Robert. We're coming up on the end of our time. I want to give you an opportunity to leave us with some last remarks. What are you most excited about, perhaps, coming up here in the next year or a few years?
Well, my main excitement today comes from one particular business area that also worries me a lot. So there's a double-edged sword. My excitement comes from looking at these constellation players there are four of the mega constellation players now when you look at OneWeb and Starlink and Kuiper and Telesat that will very likely do something there. And those services, by surrounding you with a network of connectivity, will really multiply the access that people have worldwide to the tools that we all have, internet and so forth. That's a big part of being able to educate yourself and become self-standing and make a living for yourself, is access to the internet, right? So I think from that point of view, I'm very excited about that, because there's all kinds of really cool developments in these constellations. Then they have to, fly in formation in different
Right, right. And then there's
altitudes.
the smaller players like Swarm that are serving just IoT devices, right?
Yeah,
You know,
beautiful,
so there's
beautiful,
all these
right?
layers to that.
Yeah, and it's great because we're able to do these things now relatively quickly, and we're able to create products and services relatively quickly with not huge costs. But the other side of the sword for me that really worries me is the amount of things we're putting up there. Because in
Mm,
LEO today, you have so many objects in the area where the ISS is, and just above it and below it, that are multiplying. And right now, today, there are 59,000 licensed FCC and ITU
wow.
licensed operators or satellites that are licensed today. If they're able to complete their plans and their funding and the rest of the stuff, 59,000 objects would be launched in the next 10 years. And
That's
that's a crazy
remarkable to think
number,
about.
because, I mean, today we have maybe 3,500 objects that are or satellites that are operational, that are flying around, and we're tracking about 25,000 with the tools we have.
Yeah, yeah.
We
So
know
we're
where they
gonna go
are.
up by an order of a magnitude and a half at least.
Yeah, but the space debris part of that is the other part, because there's a whole bunch of old rocket stages. There are second stage or third stage rockets that have been flying there since the Apollo days. They haven't come down, and they won't come down. And paint chips are coming off, and then they haven't been vented properly. So some of the liquid has escaped and become, basically
Oh, little pellets.
high speed pellets that can destroy a satellite without any problem at all. And they're traveling at 17,500 miles per hour, right? So uh, to me, that worries me a lot, because we're not tracking those. We're not able to track those. And again, there are a few players now that are realizing this, that they need to create some big radars on Earth and in space to be able to not only detect, but then track, and then can create conjunction analyses
Right,
for alarms,
right.
right? So that to me worries me, because today we estimate there's about 600,000 objects that are orbiting that LEO space, that are of the 2 centimeter plus size, or 2 centimeter around size, so not very big, about 2/3 of an inch. But if you look at something in the order of 2 millimeters to 1 centimeter, we're estimating about 170 million objects out there today
Wow.
that are flying at those speeds. So when
So
you
that
launch
number is
something to
hard to
space,
imagine.
it's hard to imagine. But those are the best estimates we have. And we're launching another 50, 30,000, 40,000, 50,000, whatever number you pick in the next 10 years. A lot of that, some of those will not be controllable, because they'll be dead on arrival. We'll have to, deorbit them. Some of them will not be able to control, because they'll be dead on arrival and you can't control them, and they'll become space debris objects. So to me, that's the area that really kind of worries me, because we're really putting a lot of stuff up there. We're able to manage it today, but there'll be a lot more debris warnings and conjunctions and
Events.
actual events as well, with that many things up there. It's just a question of numbers. It's mathematics. It's
Right,
probability.
right.
You
It'll
know.
be statistical. Well, Robert, thank you so much for taking the time with us today. We've covered a lot of ground, from the global, from the global nature of space to the layers of space, different orbits, different types of business, and the different perspectives, government and versus commercial. So, thank you for this wonderful overview. I think we're going to be asking you back sooner than later, especially when zero G decides to, pull the cover off and let everybody see what's under the hood there. But at this time, thank you again for joining us. It's truly been a pleasure, sir.
Thank you so much, Z. I appreciate it, and happy to come back anytime. Just ask.
Wonderful. And folks, this. Thank you so much for joining us. Thank you to our sponsors. We really appreciate it. Look for future talks at America's Future Series. And also check out our full day events. All of this info is available on the website. Thank you, folks. Take care and goodbye.